Hey guys, it's the Bearded Tangent, and today we'll be looking at the amplitude and period of sine and cosine functions. So in some of the last videos, we learned how to graph the parent functions for sine and cosine. So today we're going to learn how changes to the period and the amplitude will affect how we graph these functions. So first we're going to look at the amplitude. Now, up at the top here, I have the formulas written that we'll be using for period and amplitude. Amplitude is going to be represented by the A, which is the coefficient of your sine or your cosine function. Now, amplitude is the absolute value of A. So whether I have a positive or negative number, the amplitude is going to be the positive value of that number, how far it is away from zero. All right, so let's take a look at these and how we would graph them. Now, on number 1, I have y equals 1/2 sine theta. Okay, so I don't have any change to my period. That would be if I had a coefficient on theta, and in fact none of these we will deal with that at all. We're just going to focus on the amplitude for this round of problems. So I see that I have 1/2 as the coefficient of sine. So 1/2 is going to be my amplitude. So 1/2 equals the amplitude. All right, so now I want to graph this. So how I label this is I'll come up here to the top part, and this will be positive 1/2. And then down here at the bottom of my graph, I'm going to have negative 1/2. So the amplitude is how far away it is from the midline here. So it's not a quarter and negative a quarter because the whole thing adds up to 1/2. It's 1/2 and 1/2. The whole thing would be a distance of 1. So it's an important distinction to make. All right, so other than that, we would just graph this normally. So it's a sine graph. So we would start at our midline here. We would go up to 1/2 at my maximum. At pi over 2, at pi, we'll be back at 0. At 3 pi over 2, we'll be at our minimum at negative 1/2. And at 2 pi, we'll be back at our midline. And so you would get a sine graph that looks just like this. All right, so let's look over here at number 2. I have y equals 2 cosine theta. All right, so again, the amplitude is going to be the coefficient on cosine. And this 2, we take the absolute value of that, so we're just going to have 2. So I want to label my graph. So my maximum is going to be positive 2. My minimum will be negative 2. And other than that, we just graph this just like we would a parent function for cosine. So cosine is going to start at 2. At pi over 2, it would be at 0. At pi, it's going to be negative 2. At 3 pi over 2, it'll be back at 0. And then at 2 pi, it'll be back at positive 2. So if I just change the amplitude, all it changes are the minimums and maximums of my graph. My graphs still are crossing their x-intercepts at the same point. They're still hitting their minimums and their maximums at the same points. The maximums and minimums have just been magnified to match the coefficient on our function. So if we move down here to number 3, now we have negative 3 sine of theta. All right, so we want to do our amplitude. Remember, it is absolute value, so our amplitude is going to be 3. Okay, so we want to go ahead and label this as well. We're going to have 3 as our maximum and negative 3 as our minimum. Okay, it's a sine function, so we'll put our first dot at 0. All right, but now I have to take into consideration that this function has a negative value, and that will change what the graph looks like. So if I'm graphing a sine function and my coefficient is negative, that means instead of starting the function by going up, we're going to start the function and go down towards the minimum. So that means at pi over 2, I'll be at negative 3 instead of positive 3. At pi, I'll be back at 0. At 3 pi over 2, I will now be at my maximum instead of my minimum. And then at 2 pi, I would be back at 0. So if we graph a negative sine function, it just flips our graph. So our positive sine function starts by going up, then it comes down, then back to the midline. Our negative sine function goes down, then up, then back to the midline. All right, let's look at the negative cosine function. So here I have y equals negative 5 cosine theta. All right, so Again, we want to take the amplitude. Amplitude is going to be the absolute value of negative 5, so that's going to be simply 5. I'm going to label my maximum as 5, my minimum as negative 5. All right, so now I want to graph my cosine function. So since this is negative 5, just like the sine function, our negative value will affect how we graph this. So normal cosine function would start at positive 5, but since this is negative 5, we start our cosine function down at negative 5. All right. At pi over 2, it would still be at the midline. At pi, we will now be at the maximum at 5. At 3 pi over 2, we're going to be back at the midline. And then at 2 pi, we're going to be back at our minimum. So changing the amplitude is not very difficult on these graphs. The graphs will look relatively the same as they had before. It's just going to increase the maximums and the minimums of the graph. The only other thing to watch out for is our negative values here that we have on the coefficients. For a sine graph, that simply flips it, so it still starts at the midline. It's just going down first, and then the cosine graph, instead of starting at the maximum, it's going to start at the minimum, and then will go up and back down. So both of these graphs get reversed by having a negative coefficient. So in the next video, we'll learn how changing the coefficient of theta will affect the period of these graphs. So thank you guys for watching, and stay tuned for the next one.